Hello, welcome. We have a question on logarithm, WASSCE 2008, question 11A, section B, elective mathematics. So given that the log of 4 base x is equal to -2, we have to evaluate log x base 8. So simply put, if we know the value of x from the first expression, we only introduce it here and see what evaluation we can get or what value we can get when we replace the x with what value we get in the first logarithm. So let's see how we can do that. So we are beginning with the first logarithm, which is the log of 4 base x equals to -2. If you can recall, from logarithm we can move to indices, picking the same base. So the base will raise to the power this to give us the argument, meaning x to the power -2 will be equals to 4 if we were to change from logarithm into indices. So applying the laws of indices here, a negative power give us a fraction or the reciprocal of the base. So this is going to mean 1 over x squared equals to 4. I believe you get that. So if we are changing this to become positive, so we have it as positive. Don't forget there's a 1 here. We can cross multiply to have 4x squared equals to 1. But we are looking for x. So we divide here by 4 by 4. Meaning that your x squared will be equals to 1 out of what? 4. Okay, if that's the case, we need the x, not x squared. So we find the square root of both sides. Your x will become, the square root of 1 over 4 will be 1 over 2. I believe you know it to be -1 over 2 and a positive 1 over 2. But the x here we are looking for is a logarithm, which cannot be negative. So this x can only be a positive value. Alright, so we pick the positive value for x. Then this implies that our log of x base 8 will be equals to, whenever I see x, I introduce 1 over 2, then the base. So this is what we are looking for. We need to evaluate this and see what value we get. We can solve this in different ways. Let's see how many of the ways we can pass through to arrive at the value. Don't forget, whatever we get will be equals to this. So let's continue ignoring the left, picking the right. Here is a logarithm of 1 over 2, which we can write as an exponent of negative from the same definition. The reciprocal gives you a negative. So we can also find a negative exponent from here to have our log of 2 exponent -1 base 8. I guess we can do that. Good. If that's the case, let's bring it to bear. The power rule. The negative goes to multiply. So that gives us a -1 log 2 base 8. What we can do is that I am seeing 2 times 2 times 2. That's 2 exponent 3. Give me 8. So if I want to get this back, I can also say that 8 exponent 1/3, which is the same as 2 exponent 3 1/3. You know, we are looking for 2. If I raise it to the power 3, I'll be getting 8. But if I multiply it by 1/3, it will cancel to get me back the 2. So I can rewrite this as negative log of 8 exponent of 1/3 base 8. So are you seeing that we have the same number now? Exponent come forward to multiply. So if the exponent come to multiply, it will give you -1 times 1 on 3, the log of 8 base 8. Don't forget that log 8 base 8 will be equals to 1. Log 8 base 8, a log of a number to the same base will give you 1. So it means that we are only going to multiply -1 over 3 by 1. Therefore, the log of x base 8 is just -1/3. I believe you get it. All right. Let's see if you want to use another approach After doing all this, we can pick it from here and have negative log 2. Okay, let me just break it down. Okay, log 2. Then this is going to be 2 exponent 3. Remember that if you have 2 exponent 3, it gives you 8. So we can do this for the base also. Now, in the case of the argument, if we have an exponent, the exponent comes forward to multiply. Then, if we have a base that has an exponent, the exponent can also be transferred to the back, in this time to divide, not to multiply. From the argument, it's multiply. From the base, it's divide. So it means that this is going to divide. Don't forget there's a minus 1 here. It was this one we send to become minus 1. So that minus 1 will be there, divided by this power. Then the log of 2 base 2. And from the same principle, a log of a number to the same base is 1. Log 2 base 2 will give you the value to be 1. Therefore, you still have your negative 1 on 3 as the solution. Then let's see if we can try another aspect. So, okay, let's use this one. The log of 1 on 3, okay, 1 on 2, right? Base 8. How are we going to do that? We can see that we can employ the change of base principle. You know, if we are changing the base, log A base D can be given as log A base of C. Let me write it. If in case I have the log of A base B and I want to change the base from B to C, it can be written as the log of A base C divided by the log of B base C. We are changing the base. So therefore, the A here remains the argument with a different base. The base becomes the argument with the same base. That's change of base. So let me change the base from 8 to base 10 so that I can easily operate this. Okay, let's move this way. This is going to be the log of 1 over 2 base 10 divided by the log of what? 8 base 10. If I don't write the base, it means it's in base 10. What do we do? Let's continue to simplify further. So we have log 2 exponent minus 1, right? This is a fraction divided by the log of 2 exponent 3. 2 exponent 3 gives you 8. So now if you bring the powers out to multiply, you'll be having negative 1 times the log of 2 base 10, right? Divided by, what are we having there? We are having 3 multiplying the log of what? 2. We see clearly log 2 base 10 divided by log 2 base 10. They can cancel themselves, giving rise to only the negative 1 in the numerator, then the 3 in the denominator. So passing through this way, we can be able to get the answer. We can also pass through here or pass here. I guess you're able to follow the 3 approaches. The one that you prefer, you keep it up, but keeping your hand dirty on the 3 helps in solving some questions that may demand these principles. Thanks for watching. Like, share, and comment. Don't forget to subscribe to the channel on YouTube and follow on Facebook. Bye-bye.